4. Was that it? Yeah, okay. Will I do number 2? Yeah, okay. A biologist puts 100 bacteria into controlled environment at the start of an experiment. 6 hours later, so at the start is 0 hours, girls, right? So at the start there's 100 bacteria, right? 6 hours later, right? Okay, it's 450 bacteria. That's not a great pen now. Hang on. Okay, so at 0 hours there's 100 bacteria, and at 6 hours there is 450. Okay, assuming the exponential growth of the form y equals a times e to the power of, I can't even read that, bt, where b is the growth constant, find the value for b correct to 2 decimal places. Right, okay, y is the amount of bacteria, okay, a is a constant, we don't know what it is, e is 2.7 whatever that number, right, b we don't know, t is the time in hours, right, okay, so we have 2 bits of information here. When t is 0, y is 100, okay, so e to the power of 0 or b times 0. Agreed? That's the first piece of information. I can do something with that, right? 100 is equal to a times e to the power of 0, 0 times b is 0, and anything to the power of 0 is 1, so that's a times 1 equals 100, so that means a is equal to 100. Is that okay? So that's the first piece of information, tells me a is equal to 100. b is 0, remember anything multiplied by 0 is 0, right, and e to the power of 0 is 1, anything to the power of 0 is 1, right. The second piece of information was y was 450 at 6 hours, okay, so I've just figured out a is 100, right, e to the power of 6b, would that be okay if I just wrote, instead of b6 I wrote 6b, I magnified that small bit. Okay, is that alright? That says 6b. Right, so divide by 100. Okay, divide each side by 100. And you get 4.5 is equal to e to the power of 6b. Agreed? Get the log of both sides. Your choice. Right, okay. I'm going to get ln. Why am I going to get ln? Because ln is log to the base e, right, okay, and it'll make things handier because log to the base e of e is 1. Agreed? So I'm going to get ln, which is log to the base e, so ln of this side equals ln of this side. So remember, ln is log to the base e. I can bring down the power in front, so that's ln 4.5 equals 6b ln e. ln e is log to the base e of e, which is 1. So that's 6b times 1 equals ln 4.5. Okay, and then that's... So I'm writing that the other way around. 6b equals ln 45. Is that alright? Oh, push it over. Yeah, sorry. And then divide each side by 6, and you'll get b is equal to ln 4.5, or ln, that's 4.5 divided by 6, which is what it is, and you would round it up to 2 places decimals and get the answer. Is that okay? So you can finish that off in your calculators. Are we good with that? They're very noisy upstairs, but that's because it's lunchtime for them. Do you have an answer? Will I just to have it complete? 0.25. Yeah. Okay, just to have it complete. Is that alright? Questions? Problems? Remember, anytime the variable you're looking for is in the power, you need to get the log of each side, right? Your choice of base, I chose base e here because by choosing base e, I'll end up with log of e to the base e, and that's just 1. Okay, it just saves me typing a few numbers into the calculator. But if you got the log to the base 10 on both sides, you just have to divide by log to the base 10 of e, right? Is that okay? Right. Okay, number 3. I'm doing it, I presume. Am I? Yeah. Okay, number 3. Milk for a baby which was heated up to 45 degrees is left to cool. Right, okay, so at the start, girls, it's 45 degrees. Okay, this one's slightly different, okay, because normally at the start it's 0. But, right, when T is 0, the temperature is 45 degrees. Agreed? Because they're heating it up and then they're starting the timer. Right? The temperature T of the milk after T minutes left cooling is given by T is equal to, so T is the temperature 15 plus 30 multiplied by 10 to the minus 0.2 T. Right? So capital T is the temperature, small t is the time in minutes, it told me. Right? It told me in the question it's in minutes. Yeah? Minus 0.02 T. Is that right? Okay, and that formula was given in the question. Okay? Verify that the initial temperature was 45 degrees. So that means when T was not, show that capital T is 45. So all you do is T is equal to 15 plus 30 multiplied by 10 to the power of minus 0.02 times T was 0. So at the very start, right, start T is always 0, right, and put that into the calculator and you'll get T is equal to 45. Is that okay? Good with that? Right, part 2. If the milk is left, if the milk is to be given to a baby when it has cooled to 35 degrees, how long has it to be left to cool to reach this temperature? So we want the temperature to be 35. So we want capital T to be 35. The time is what we're looking for, so we're looking for T. That's what we're looking for. Is that okay? So fill in capital T is 35 equals 15 plus 30. Can I just change that multiply to a bracket? Okay. The reason I want to change it to a bracket is because it's starting to look like an X and I don't want it. Is that okay? So I just change that multiply sign to a bracket. Are we good with that? First thing you do is you bring over your 15. So 35 minus 15 equals 30 times 10 to the minus 0.02 T. Is that okay? So that's 35, so I just brought over the 15 and made it a minus. So that means 20 equals 30 times 10 to the minus 0.02 T. Okay, and that would be, then divide each side by 30. And I'm just going to turn it backwards if that's okay. So when you divide by 30, at one side I'll have 10 to the power of 0.02 T equals, and 20 over 30 simplifies to 2/3. Is that okay? Is everyone alright with that? I just wrote it backwards. Are we good with that? Right, then, because the T, the variable you're looking for, is in the power, you need to get the log of each side, yeah? Log to the base, what did I do? 10. Right, okay, log to the base 10. So log to the base 10, which is just the log button in your calculator, minus 0.02 t is log to the base 10 over here of 2/3, yeah? So I got the log to the base 10 of each side. Okay, over here I can bring the power down in front, so it's minus 0.02 t log to the base 10 of 10 equals log to the base 10 of 2/3, and log to the base 10 is 1. Log of 10 to the base 10 is 1. Can I move it up? Is that okay? So that's just 1. So I'll get minus 0.02 t is equal to log of 2/3. And then divide each side by minus 0.02. Divide that side by minus 0.02. So into the calculator with fraction button, log of 2/3 on top, minus 0.02 on the bottom. And you end up with t is equal to, and it said, it doesn't say rounded up to any place of decimals, so has anyone got an answer? Say that again? 8.8 minutes. Is that alright? Are we good with that? Yes.
So do you know, before you put it over 0.02 on the
Yeah.
2/3 side, where does the time go from the log?
Oh, I just didn't write it down. Because log without a base is understood to be log of 10. Okay, I just stopped writing it because I got tired.
That's
Is that right? Okay, yes.
Are you cancelling off the 2 minus point? Yeah.
Is that okay?
Yeah.
It's like 2x equals 6. You know, the way you divide each side by 2. Okay? That's, yeah. Ye probably learned not to write it that way, so, yeah. You don't have to write it. You could just bring the minus 0.02 over. Is that alright? Okay, are we good? Questions? Right, okay. Part 3. Use this rule to find the room temperature explaining your answer. Right, okay, so room temperature, so we have, so basically, how much is the milk going to cool? It's not going to keep going down, sure it's not. Right, it's going to stop when it gets to room temperature, isn't it? You know that, right? If you leave a bottle of milk on the table, it's not going to get colder and colder and colder. It's going to get to room temperature and stop. Right? Agreed? Okay, sorry. So, temperature is equal to 15 plus 30 times 10 to the minus 0.02 t, right? Would you agree this is getting smaller and smaller, right? As that goes, as time gets bigger, this gets smaller. Would you agree? Right, okay. So that's kind of heading for naught, isn't it? Right? Would you agree? As time goes on, 10 to the power of minus 0.02 t gets smaller and smaller, right? Check it out in your calculator. Do t is equal to 1 minute, t is equal to 10 minutes, t is equal to 20 minutes, etc. Right? And that is, it's reducing. When it's to a minus, it's getting smaller and smaller. You know, when the power is to a minus, that's heading for a smaller fraction and smaller fraction and smaller fraction. So if it went to infinity, that would go to 0. Would you agree? Right? So that value there is heading for 0. So the temperature is heading for 50 plus 30 multiplied by 0. Agreed? Right, okay, so that means the temperature is equal to 15 degrees. So room temperature is 15 degrees. So that means it's going to cool until it gets to 15 degrees. Now it's heading for 15 degrees. Okay, so eventually it'll get to 15 degrees and that's as far as it'll go. Is that alright? Okay, so that's kind of known that 10 to the, any base to a negative power is getting smaller. Right? Any base to a negative power is getting smaller. Any base to a positive power is getting bigger. Okay, so 10 to the power minus, as t goes up and up and up, that's getting smaller and smaller and it's heading for 0. Now it'll never actually get to 0 because it's an exponential, but it's heading for 0. Okay, so that's all That's all you have to say. It's getting smaller and smaller, so that means that that's getting nearer and nearer to 15 degrees. Is that all right? Yes.
How do you know to put the, like, how do you know to get the 0 out of 10 to the power minus?
And that's what I'm saying, is 10 to a negative indice is always getting smaller. 10 to a negative indice is, it's going to be a fraction, and then a smaller fraction, then a smaller fraction. And yeah, so you need to remember that any base to a negative indice is always getting smaller and smaller, and it's a fraction, and the fraction's getting smaller and smaller, so it's heading for 0. Okay.
Why, if it's only, like, I don't know get how, like, if it doesn't get to 0, why is it multiplied by 0?
Because it's so teensy. It's going to get so teensy. We're going to be the temperature is 15.0000000001. Okay, so it's 15. Is that right? So it's never actually, but you'll never have a thermometer that will measure that many decimal places. Do you know what I mean? So all thermometers will round it to 15. So it'll never actually get to exactly 15, but when we round it, it's 15. Is that okay? Right, are we all good with that? Right, number 4, I presume I'm doing it? Yeah. Alright, okay, so number 4, the loudness measured in decibels of a sound is given by the formula. So the loudness is given by 10 times log to the base 10 of I over I0, right? Where I0 is the threshold of hearing, which is 1 by 10 to the power 12. You see that I0? They should have just written in the number. They just told me that that is 1 by 10 to the power of minus 12. Okay? Is that right? So I0 is 1 by 10 to the power minus 12. So they put in a letter there and they didn't need to. They could have just put the number in for you. Right? Okay, so I0 never changes. It's always 1 by 10 to the power minus 12. They told me that in the second line. Right? And I is the intensity of the sound. If the thunder can range from loudness between 100 and 110 decibels, this is the decibels over here, right? So it ranges from 100 to 110. What is the corresponding range of intensities? Okay, there's two sums in that. You have to do it when L is 100, and you have to do it again when L is 110. So there's actually two sums in that, okay? So they're saying it's between 100 and 110, so you have to get a corresponding I for 100 and a corresponding I for 110, and that's your range of intensities. Is that all right? So there's two sums in one in there, right? So L is 100, so that's 100 equals 10 log to the base 10 of I all over 1 by 10 to the power minus 12. Is that okay? So you divide each side by 10 to get rid of that 10 there in front. Okay, and over that side you'll get, sorry, clean board, where is it? No place. You'll get 10 equals log to the base 10 of I by 1 by 10 to the power of minus 12. Is that alright? Okay, we have a log equal to a number. When you have a log equal to a number, what do? You turn it back into a what? An index, right? So when you have a log equal to a number, you turn it back into an index, okay? So in the previous questions, we always had an index and we used logs to go backwards. This time we have logs, so use indexes to go backwards. Do you know what I'm saying? So you go, this is the base, this is the power, this is the answer. That's I all over 1 by 10 to the power minus 12. Is that okay? Shall I finish that off? Cross multiply? Yeah? Okay, so that's over 1. So 1 by I is I, and over here that's 10 to the power of 10 multiplied by 1 multiplied by 10 to the power of minus 12. into the calculators with that, and you'll get I is equal to 10 to the power minus 2, which is 0.01. Is that okay? We good with that? Yes.
Could you just go back on how you got the 10 or 10 by
The here,
down the next one?
this one,
Yeah.
I just cross multiplied. So 10 to the power 10 is just a number over 1. So 1 by I is I, and 10 to the power of 10 multiplied by 1 by 10 to the power minus 12.
Oh.
Okay, and then you put that into the calculator and you get 0.01. Right, I think, assuming my calculations are right. Is that alright? Okay, so that's one end of the intensities. Right, okay, so now I have to go and do it again. This time I'm using 110. So 110 is equal to 10 times, so I'm filling in 110 for L, log to the base 10, and I'm looking for I all over 1 by 10 to the power minus 12. Is that okay? So same thing again, divide each side by 10, okay, and you'll end up with 11 equals log to the base 10 of I all over 1 by 10 to the power minus 12. Okay, when you have a log equal to a number, turn it back into an index. So here's the base, 10, here's the power, here's the answer. I all over 1 by 10 to the power of minus 12. And again, to finish that off, cross multiply. So 1 by I is I, cross multiply here, 10 to the power of 11, multiplied by whatever is below the line there at the other side, 1 by 10 to the power minus 12. And that would be I is equal to 10 to the power minus 1, which is 0.1. Okay? Is that alright? So they told me that the loudness was between 100 and 110. What's the intensity between? It's between 0.01 and 0.1. Is that alright? Yes.
What's the first power in the for last line?
Here,
Yeah.
10 to the power of 11. It's that. There. Sorry. Right, are we good? Questions? No. Right, okay. Time-wise, how am I going? I'll do will I do question 5 now? And I'll leave you a few more to do with the weekend. You might have noticed on Teams I put up an Algebra 3 revision sheet. Okay, you're going to work on that over the weekend. Okay, so the Algebra 3 revision sheet, there's one question from every section. Right, okay. Remember, I didn't do the section on the last 3 sections on induction. I'm leaving out. Well, it's less one section, but they say A, B, and C. And I also left out 12.4. Okay, so 12.4 is left out as well. Is that all right? Yes. Yeah. Okay. So do you want to? We'll do question 5. Will we do question 5? We will. Right. We'll do question 5 now. You can stick this into your copies as example 2, because I think I only got one done yesterday. Would that be right? Okay. So example 2. Right. The amplitude of an earthquake . Do you know, I'm just going to write page 497, question 5. Will you copy the question in tonight? Rather than me writing it out and you copying it down, and I'll just put it up here and we'll read it. Would that be okay? You'll get to lunch earlier, so it'll definitely be okay, yeah? Yeah? Right, okay. So I'll just magnify it here and we'll read it here and you can copy it in so it's in your notes for tonight, okay? So we have, right, the amplitude of an earthquake is given by A equals 10 to the power of n. This is on 497. 497 question 5. So A equals 10 to the power of m, where m is the magnitude of the quake on the Richter scale. The energy released by the earthquake is given by energy equals 10 to the power of 1.5 m. I know you can't see this, but I'll just rewrite it, show you in a minute. I'm just reading the question, right? Using the rules of logs, find a and b such that e equals 10 to the power of a by a to the power of b. Basically, they want you to start with this equation that they gave you and rearrange it so it looks like 10 to the power of a times a to the power b. Play around with it, basically, and use your laws of indices, right? Okay, so I'm starting with this and I'm going to play around with it. It's 1.5 n. Sorry, I'll make that a bit bigger because e equals 10 to the power of 1.5 m plus 4.8. Okay, that's what they give you, and they want you to play around with it so it looks like this. Okay, so it looks like that. Is that all right? Okay, rules of indices, right? So the rules of indices says, right, if you added it, what was it originally? Multiplied, wasn't it? So that was originally 10 times 1.5 to the power of m multiplied by 10 to the power of 4.8. Would you agree? I put a dot for the multiply instead of a multiply sign because I don't want you to think it's an x, right? So, you know, if you had 2 to the power of 3 multiplied by 2 to the power of 5, you would tell me that was 2 to the power of 8, wouldn't you? Right? So if you 10 to the power of that multiplied by 10 to the power of that, you would add them, add the indices, wouldn't you? Agreed? Yeah, I'll take that as a yes, we agree. Right, okay. Now look, I know if I have 10 to the power of m, I can write a capital A instead of it. So E is equal to, so instead of writing 10 to the power of 1.5 m, I'm going to write 10 to the power of m all to the power of 1.5. Would you agree? Multiply by 10 to the power of 4.8. Agreed? Right, okay, so that's E is equal to 10 to the power of m. I can write that as A, can't I? They told me that at the top of the sum, right, that A was 10 to the power of m. So instead of that, I can write A, capital A, so that's A to the power of 1.5, and this is multiplied by 10 to the power of 4.8. Now, I'm almost finished because they told me to write it as 10 to the power of something multiplied by a to the power of something. So what would small a be equal to? 4.8. It's whatever is 10 to the power of what? And what would small b be equal to? 1.5. And I'm done. Okay? So it looked pretty complicated, but it actually wasn't in the end. Okay? Right, what I'm going to do is that sheet I put up in Teams, right, you're going to work on that for the weekend and you're going to come with the questions on Monday. So I need you to go over this. I need you to go over this, right, on Monday. Remember, you're getting a test on this chapter on Tuesday, right? Okay, bar the last section on induction and 12.4, I said, wasn't it? Mathematical proofs it's called anyway, right? Okay. So the sheet has gone up and it's basically one question from each section. So make sure you can do each question from each section, and if you can't do them, come on Monday and say do this one, do this one, do this one. Right? Okay, go.